Let's consider two light waves. This is one of them. I mean, it's still continue. Okay, now another one, also same. We will continue. Okay, now if both these waves, okay, start off at the same time, you can see they are in phase. Okay, when this one reach the maximum, this one also reach the maximum. When it reach the zero position, this also. Okay, actually these two, let's say these two from the same source, and they come from the same point. I mean, they all started at this. Okay, now then this minimum, this also minimum. So this one 0 is 0. Now, if I overlap these two together, what happens is this maximum and this maximum will reinforce each other. So in other words, if I put them together, if I overlap both of them, I mean when these two waves cross path, they touch each other, travel in the same direction, and they are in phase, then the resultant will be something almost double. Okay, so you can see that it actually if they're in phase, okay, in phase means the timing is correct, then the result is actually constructive interference. When these two waves meet together, it's constructive, means it amplify each other. When this go up, the resultant also go up, and these two go down, the resultant also go down. So that means the intensity, the strength become even, the amplitude become even higher in this case. Okay. Now, what happens if you have the case? Now let's look at a different scenario. We have one wave travel in this direction. The timing is this start off with 0 versus the other wave where it start off is actually already half. It's already half of the period, so it actually go down. Okay, this is the beginning, but then the second half actually go down. Okay, so there is the timing is slightly different. Okay, so in this case, if these two waves overlap each other, what happens is, let's say you consider this point. This positive, this fully negative, maximum positive, maximum negative, because they are in a different cycle, so they actually cancel out. Similarly, this one positive, this one negative, cancel each other. So as a result, you will get the result is you will get totally, you couldn't see the wave. Okay, it's actually 0. Okay, you get it? So when you're out of phase, totally 180, or we call it the half a T out of sync with this, then you get a result of this. So basically, this case, we were talking about a case whereby, okay, it's talking about, okay, from here, then so if there's one source of light, a source of light coming from this side here, Okay, so what happened is at this point there will be diffraction happen. Okay, similarly there will be diffraction happen. Okay, both of these, okay, seen from the same source, they will have the same phase. Okay, they have the same phase. The starting point is the question here basically is referring to okay, let's consider the middle point here. Okay, this one is you travel from here to here. Since they start out with the same phase and this equal distance from these 2 points, this one is equal distance from the 2 points. So the light will reach here in this condition. That means you would see a bright spot here. Okay, now then what happened is you see, if this travel a certain distance, when it reach the screen, okay, we haven't considered the screen. Let's say this is screen. Okay, now let's say okay, now let's say this is P, this S1, this S2. Now what it's saying is if this P is a dark spot, that means you actually end up this, okay, end up this situation. That means the destructive interference, that means they cancel off each other. So when they reach here, at this point here, there's a destructive interference. That means you won't see any light. So if this is the case, then this thing must happen. Okay. Now, okay, let's take for example this from S1 to P. Let's say you have traveled full length. Let's say it is 10 lambda. Okay. At this point, you have reached 10 lambda. So you're going to start, but then you're going to start the next cycle. Okay. That means you have gone through 10 before. But what happened here is actually 10 pi lambda. Okay, you have taken a distance 10.5 lambda when you reach here. So what happened is 10 lambda means at this point you're going to start this. Okay, but 10.5 lambda means half of the period had gone. So you're going to start at this point, you're going to go below because there's 10.5 lambda. Here to here is the full wavelength, but then by the time you reach here, you're already at this spot, so it's going down. But whereas when you reach 10 lambda here, okay, you start to going up the wave. So when this happens, then you got a destructive interference. In other words, they will cancel off each other. Okay, there will be a dark spot here. Okay, but if for example instead of 10.5, you end up 11 pi. Okay, 11 lambda. So what happened is for this S1P reach here is 10 lambda, so it's going to start from here. Then if take the case from here to here is 11 lambda, that means reach here is 11 lambda. He also going to start the cycle. So when you have 10 pi, 10 lambda, 11 lambda mean this is 10, so you're going to start, okay, this way. You will have 11 lambda reach this point here, so it's going to start here, okay. So that means there is a constructive interference, that means it becomes brighter, okay, they add each other. So in other words, this distance minus this distance, if we end up with a whole number for lambda, then it will be a bright spot, okay. You can have another point here, okay. This the P here is actually the dark spot, okay. So it is 10.5 minus 10 lambda, 10.5, so you get 0.5, okay. And then next to it, okay, next to it, this is dark, okay, this is dark. Now next to it, there will be another point, let's say you call it a P1, this will be bright. Why? Because as I say, by then it could be maybe by then P1 here is 10.5 lambda, this one could be 11.5 lambda, okay. So you take, that means to say when you reach here, reach this point here P1, they are all at this condition 10.5, so it's already half cycle already passed, so they're going to start here. Similarly, this 11.5 also they're going to, when they reach this point, is actually going down, so they actually it's a constructive, they are in the same phase, so this becomes a bright spot. So bottom line is that the distance, when you the longer one minus the small one, it has to be a whole digit lambda. That means it can be 1 lambda, 2 lambda, 3 lambda, okay, for it to have a bright spot. But if you have a half lambda, 1/4 lambda, okay, if you have a half lambda, then it's totally destructive, that means totally there's no light at all. But if you have, let's say you end up here as 1/4 lambda, then it will not be total brightness, but it will not be as bright as when you have a whole a multiple of lambda, okay. If you have this, then it's even brighter than just one of them, even brighter. Why? Because they reinforce each other, constructive interference. Okay, when you have half, okay, or you have 1.5, okay, or you have 2.5, then they are actually totally in opposite direction with each other. Then if that's the case, then it is dark. But in between, you got 1/4 lambda, you got 2 or 3 lambda. The difference I'm talking about, all the difference, this minus this, then it will be somewhat in between, okay, somewhat in between in terms of brightness. This is even brighter, this is total darkness, you cannot see anything there. Then if you have something that is not half or whole number, whole multiple of the lambda, then you're somewhat in between. Not total darkness, also not that bright. Okay, so for this question, we say that P is the dark fringes. Okay, that means when you minus the distance, you end up either half, 1.5, or 2.5. So if this is the case, then the answer would be this. When you have dark fringes on the screen. Okay, assuming that is actually total dark, not somewhat in between. Okay, that's it.